In this lecture, we'll discuss the beta-lactam, beta-lactamases inhibitors. And the beta-lactamases are enzymes that destroy the beta-lactam ring. So all the beta-lactamases that destroy them, when the ring is destroyed, the beta-lactam lose its action, beta-lactam antibiotics. And we have a broad classification of the beta-lactamases. There's some group acting on the penicillinases, that the family are family of enzymes which confer resistance to the penicillins, and there is other family of called cephalosporinases, that the family of enzymes which confer resistance to the extended spectrum cephalosporin. And the last family of the beta-lactamase is called carbapenemases, which is enzymes that confer resistance to the carbapenems. And if we look to this classification, the penicillinases, that the enzymes that inhibit the penicillin are TIM and SHV. And according to the ampler classification, this is called class A beta-lactamases enzymes. And the inactivated beta-lactam is penicillin and first generation cephalosporin. And for bacteria that inhibit the cephalosporinases, we have two enzymes, either CTXM and AMPC. And according to the ampler classification, this CTXM is class A and AMPC is class C. And the bacteria that have secrete this enzyme, it inhibits second, third generation cephalosporin plus or minus fourth generation cephalosporin. And for carbapeneses, we have three groups of enzymes, KPC, metallo-beta-lactamases, and oxovariant. The metallo-beta-lactamase is subdivided into three subtypes, NDM, VIM, and M. For KPC, it is a class A for ampler classification. For MPL, in the class B. For oxovariant, in the class D. All these types of carbapeneses inhibit the carbapenem and the other beta-lactam antibiotics. And beta-lactamases inhibitors are compound that developed by pharmaceutical company to inhibit the beta-lactamases, so it protects the beta-lactam against the beta-lactamases inhibitors. We have all beta-lactamase inhibitor like sulbactam, clavulanic acid, and tazobactam. We have a newly approved beta-lactamase inhibitor like avibactam, virbactam, relibactam, and urolibactam. And there is some new beta-lactam inhibitor in the pipeline like zidibactam, nacubactam, and metazobactam. And if you look to this spectrum and for of traditional and the new beta-lactamases inhibitor, how it inhibit the beta-lactamases. For the traditional one, the clavulanic acid, tazobactam, and sulbactam, all these types of beta-lactamase inhibitor, it inhibits the penicillinase enzymes. Have some variability against the CTXM as a cephalosporinases, but it doesn't inhibit any of MPC or KPC or carbapeneses enzymes. So the tazobactam, sulbactam, and clavulanic acid does not inhibit the carbapeneses beta-lactamases enzymes. For the new generation, avibactam inhibit penicillinases, cephalosporinases, and some type of the carbapeneses like the KPC and OXA48, but it doesn't inhibit metallo-beta-lactamases or OXA24 or 40. For vaporbactam and relibactam, it has the same spectrum of the avibactam, except it doesn't inhibit metallo-beta-lactamases. The newly one, that durolopactam, the newly approved one, it's inhibit the OXA24 and OXA40 and OX48. That's why the durolopactam, it's used with sulbactam for Acinetobacter, because the Acinetobacter, the carbapenem-resistant Acinetobacter, the main mechanism of resistance is for by acquiring the OXA24 and OXA40. So there is the approved beta-lactamase inhibitor is the ceftazolone tazobactam, ceftazidime avibactam, meropenem vaporbactam, imipenem relibactam, and sulbactam durabactam. So these are the newly approved beta-lactamase inhibitors, but there is some new beta-lactamase under development, like astrinam avibactam, cefepime zidibactam, meropenem nacuibactam, and the cefepime in metazobactam. And for the already approved molecule, ceftazidime is approved in 2014 under the trial called ASPECT UTI trial. And this trial is non-inferiority trial comparing ceftazidime versus levofloxacin. Ceftazidime is approved in 2015 under the trial is called the recapture trial, and it's also a non-inferiority trial comparing ceftazidime versus doripenem. In meropenem veperpactam approved in 2017 under trial Tango 1 trial comparing meropenem veperpactam versus piperacillin tazobactam. Imipidem relebactam approved 2021 in Restore Imipidem trial. It compared imipidem relebactam versus imipidem plus colistin. And lastly, in 2023, the Salbactam, Dirulbactam approved for Acinetobacter, Copaprim-resistant Acinetobacter for under trial called ATTACK trial. It compared imipidem plus Salbactam, Dirulbactam versus imipidem plus colistin. And here is the spectrum of the newly approved beta-lactamase inhibitor against the enzymes of beta-lactamases. Ceftazine avibactam used for CTXM, MPC, KPC, OXA48, but cannot be used alone for beta-lactamases for enterobacterals. For Pseudomonas, it has some effect on MPC, it has some effect on KPC, but it has no effect on metallo-beta-lactamases alone. It doesn't cover any types of the carbapenem-resistant Acinetobacter. For ceftolozane-tazobactam, it covers enterobacterals, cephalosporin resistant like CTXM and MPC have no effect on the enterobacterals that are resistant to the carbapenem. It have excellent effect against non-carbapenesis producer Pseudomonas, but it has no effect on the carbapenesis producer beta-lactamase like KPC, OXA48, and metallo-beta-lactamases. Meropenem vaporubactam and imipenem relebactam, both of them can cover enterobacterials, either cephalosporinases, that secrete enterobacterials that secrete cephalosporinase like CTXM and MPC, or enterobacteria that secrete KPC, but that has no effect against metallo-beta-lactamase or OXA48. Imipenem relebactam mainly used for carbapenem-resistant Pseudomonas and Pseudomonas that are secreting MPC. And lastly, for Sulbactam durolibactam, it's used mainly for Acinetobacter, as we said before, because it has a potent effect on the OXA24 and OXA40. Thank you.